Okay, so now we know a little bit about the basics of Max. We're going to actually try to work on some Dataflow programming. So let's start with an object. And I'm going to do a really common object, which is addition. Okay, so you may have seen this, and let's zoom in just a hair here. There we go. You can see it better. So this object, if you remember from the last one, last tutorial, we have on the top are our inlets, those little circles there. Okay, data comes in. Then this portion is representative of the program. Essentially, what does the object do? It's a little program that does something. We're going to add two numbers together, and then we get the result at the end. Okay, so we need to add numbers. So we're going to grab a number and a number. And notice how these also have inlets and outlets. So we look at this one, this is the output of the number. So that's what we want, the output number, or actually the number. It's going to go into the inlets. Okay. All right, so now I'm doing addition, but notice how you have no idea what the result is because we haven't put anything down here. So I do Shift E, get out of edit mode. I need a third number. I need the result. All right, so notice now the result is not there. That's not 17 plus 11. It's not 0. We have to actually execute another command. So there we go. Once you change the number, it does the addition again. All right. So notice when we were doing the connection, it said the result is left plus right. Left inlet plus the right inlet. Okay, now there's a good reason for that we'll talk about in a second. But notice that when I change this right number, it doesn't change the result until I change the left number. Okay, so in Max, there is a concept called hot and cold inlets. The hot inlet is normally the leftmost inlet. Anything to the right is going to be a cold inlet. The cold inlets normally mean that they only change settings in this little program, the addition. They won't change the output. You have to, in order to change the output, you need to activate in some way the hot inlet. So by us activating the hot inlet, we change the number in the number box. So notice I'm just clicking and dragging on these numbers, by the way. All right, so there's a reason to that, and maybe that's not how you want it to behave, and maybe it is. If it is, then you're set. You don't have to do anything else. If it's not, then you need to do another step. Okay, but this is the idea, is most objects, if they have more than one inlet, one is going to be hot and one is going to be cold. Okay, so this is going to be the same for all the mathematic objects. There's multiplication, division, now notice it doesn't give you the fractional part. Here's where we had that problem I mentioned in the first one. This is a floating point. And all these are integers. So in order to actually get division to work, I just did Command D for duplicate there. We need to have floating point numbers. Oh yeah, and you still have to do this. Yeah. A little tiny thing about max. Another thing that annoys me is you got to make sure that it knows it wants to output floating points. Why it doesn't just do that is beyond me. Something for you max developers. All right. So we're going to stick with that. You're probably from this point forward only going to see me dealing with floats or decimal points because the real world uses decimals, my friends. All right. So now I'm going to introduce you to an object called trigger. Because let's say we don't like this behavior of this one having to change first and then this one executing it. What if we want both to change whenever we change one or the other? We're going to use something called trigger. So we control click, get help. Okay, we can read all about trigger. What trigger does is it can convert messages, and it can also guarantee the order in which the events happen by its outlets. Okay, so you can look into that little help menu there. We're just going to try something first. We're going to do Command D, put in a number. Now trigger needs what's called an argument. Argument sets different parameters within a program. And this argument we're going to give it is going to be letters that stand for different types of objects. So we're going to do a B and an F. Okay, the B stands for bang. Remember this thing here? Technically, this the data that this outputs is a bang. And then F stands for float, which is what this outputs. Now notice how there's only one inlet. It's going to convert this data into a float, which it already is. So it's basically just passing the float through and convert it into a bang. Okay? But it's going to do so float first, then bang. Okay? So we're going to look at this in the console first. Oops. New, just press the letter N. I type in the word print. This is from the last tutorial. Alright, so when I gave it a 1, it prints the 1 first and then the bang. And then it executes a bang. Should do that the same every time. If I reverse the order and do float bang, I should get a bang first and then a float. Alright, why is that important? Well, over here we want to put the number into the inlet first. Then we're going to send a bang to this inlet and execute the math so that anytime we change this number, it will execute an output and this number. So basically, this makes it hot, both of them hot inlets. Okay, so we're going to take this little logic here, and I'm going to just hit Command D to duplicate, and I'm going to delete this patch cable. And I'm going to do it like this. Take this into our inlet. This is our float, right? Order 1. Order 2 is a bang. We're going to bang that inlet. And Command E for edit mode. All right, so Dataflow. Let's just kind of talk quickly about Dataflow. It's actually really easy because it flows right now in the way you see it. Here's our starting data, flows through a representative patch cord into this inlet. Here's our representative data, flows in the trigger, gets converted into both a number which it started out as, same number passes through, goes to our inlet just like we did before, and gets converted to a bang, that's what the B stands for, goes into our hot inlet and executes it. So it does it in this order. Number, bang, okay? Oops. So we have to have it do it in that order to get this to work properly. So if we did it in the reverse order, so now this becomes the bang. If we banged first and then the number, we're going to be one number off, because it's going to do the last number that you did, then change the number. So we need to do bang float, and make sure this goes to our inlet, the float, and this goes to our hot. And now we get the right numbers. Okay, so you can try it yourself with addition, something you can check the output and just make sure that it's working the way you want it to work. But this is a way of forcing what we call order of events. Okay, so that's one little trick of Max that I wanted to get out of the way first. And it also introduces data flow. Okay, basically visual data flow is what's happening here. Now we're going to create a simple synthesizer. We're going to use a sine wave. So I hit N. I'm going to type in the word cycle. And you're going to see I get two versions. I get cycle and cycle with that little thing. What is that called? We call that a tilde. All right, and it's a sinusoidal oscillator. All right, so one thing about Max you're going to learn today is that the little tilde, which is right next to the 1 key, that looks like, actually, if you really look at it carefully, it looks like a sine wave. And that's representative in Max as anything that will run audio. Okay, those are two different worlds. What we were just working in had no audio. But cycle and others like it have audio. So we need to treat it like audio as opposed to just numbers. Those are sort of the two worlds of Max. Notice how it still has inlets, right? You can change its frequency and its phase. And the output is going to be a sine tone. So we need to connect that output to our audio out, which I'm going to introduce you to the easy DAC. It's so easy. All right. Now, notice how the patch cables change. They look like, I don't know, bumblebees, I guess. And I turn it on. You hear nothing. But you see full volume right there. But nothing's coming out. Well, what did I forget to do? I either need to give it some sort of frequency through an inlet, or I need to give it an argument. All right, so let's turn this off. I'm going to turn this halfway down. Let's give it an argument. And the arguments, you see, notice how they're listed here. Okay, really, you just want that first one for most instances. Our frequency in hertz. So now when I turn this on, we should hear 200 hertz. All right. Well, there's a synthesizer. Not very interesting, but it is a synthesizer. So we're going to delete these. We want a synthesizer where we can change the frequency and turn it on and off. Okay, so really easy. You can change the frequency by grabbing a float and plugging that into the inlet. Now here's our frequency changing. Now we don't hear it yet. Do we ever need phase? We will if we ever want to get into making more complex synthesizers, but right now we don't really need to worry about phase. All right, now we need to turn it on and off. Well, you could just use this as your on-off button, but you'll notice what happens. Okay. It turns off audio for the entire patch. So let's say if I had two. Okay, one coming out the left speaker, one coming out the right speaker. So see, that's channel 1, channel 2. All right. All right, so when I turn this off, they both go off. But what if I just wanted one to go off and not the other? You need an on-off switch. So that's what we're going to build. Need a little space here. I'm going to delete the patch cables, and we're going to make a new object. And it's going to be Shift 8, or that little star. And we're going to choose the tilde. Because we're dealing with audio, now anything of our output has to go into another object that's got audio. Okay, so anything else with a tilde will work. And this acts exactly like any other math object, except it's doing the calculations at sample rate, not at the rate that we change the numbers. So it's just really fast math, if you want to think of it that way. All right, so now, no, that's right. This is our right channel. Notice how you only hear the right channel. Well, I've put this in there, and I'm basically multiplying it by 0. And if you know, any number multiplied by 0 is going to be 0, so all we're hearing is nothing. So we need to change that. We're going to start with a toggle. This is really a hacky way to do it, but I'm going to just simply toggle it on and off. So if you multiply a signal by 1, that means you're basically passing it through without amplifying it. If you multiply it by 0, it means you're turning it off. So this works really well now as an on-off switch. Well, let's try it. Okay. Did you hear the pop? Now, I don't know about you. Maybe you're into glitch, but that's not good. We need to get rid of that pop. So we're going to do basically what's called a fade in, or really, really micro fade. Every time we turn it on, it's going to micro fade in and micro fade out. And we're going to use something called a line. So we hit N. We're going to type in line, and then we need the tilde. Okay, line tilde. And what line tilde does is it basically generates a ramp or a fade. For this instance, it's basically a fade. All right, it also needs to know, it needs a list of numbers. So if I just do this, it's not going to work because it doesn't know how long it wants me to fade in. Now I could put that in the argument, but I'm going to do it a slightly different way. I'm going to do it with another object which you're probably going to end up using called pack. And I'm going to give it 2 arguments, a 0 and then 50. Now, the 0 is just going to be the on-off, stands for the first element here. The 50, I could change it here. Oops, with a number. Not that I really want to, but I'll show you that we can do that. And it's going to pack these together in a list. That line will now know, turn it up to 1 in 50 milliseconds. Okay? So as we change it, you'll see that milliseconds are very, very short periods of time. All right, so now I turn it on. There's no click. No click at all. Which is exactly what we wanted. And there's only really 2 objects to go. So this is essentially a really simple fading tool, or really what we use it is to get rid of what's called zipper noise, which I'll show you in 1 second. I can change the length of time here. So I can say, let's try ½ a second, which would be 500 milliseconds, or something close to it. All right. You see how it fades in really slow now. All right. That's really not what we want. We want an on-off switch to be immediate, so we'll change it back to 50. 50 milliseconds is quick enough that we don't notice it. All right. Now the other thing that I can do, now I'm just going to delete this one, go, just the original, is I can get rid of this for now. Ooh. There we go. Right. If I since this was a 0 and a 1, all we have to do here is divide this number by 100, and we get a linear volume out of this number. So, that's right, the maxi things you got to do. All right, let's see if this helps. So this should be, as I go up, your volume. All right, and notice negative doesn't care, it rounds it, or it absolute values it. All right, so there's your, this is basically a volume knob, a linear volume knob. And so if I were to just circumvent, I wanted this too. If I circumvented all this logic here, you get what's called zipper noise. And I'm not getting it because, right. I need to do it this way through the line. There we go. All right, so you hear that? That's called zipper noise. All right, that's because we're not ramping up. So what, get rid of this, go back to what we had. What line is doing is it's basically taking 50 milliseconds to change the number, which basically creates a little ramp within a ramp within a ramp. So it's more or less getting rid of all this zipper noise that happens with typical volume switches. And so let's just follow the logic here. Okay, so this is all what we call logic. This, you give it a number, divide it by 100. So that now gives us a range of 0 to 1. Right? Then we pack that number in a list with 50. That's our time that we want it to ramp up. Line creates the ramp. We multiply the number, which is basically our volume, and then we can hear our cycle, which goes to our audio output. Our cycle gets frequency input from its inlet, goes in the other inlet. Okay, so this logic here becomes our volume, and this becomes our signal. And you could reverse it if you wanted to, that doesn't really matter. Okay, so now we've learned audio objects have the tilde. We've learned these little weird tricks of math, making sure that you have little dots after your numbers for floating points. Otherwise they won't work. You learned about easy DAC and a little bit about pack and trigger. If you remember trigger. Tigger. That's funny. All right. Next, we're going to learn a little bit about basically using MIDI. Okay. So, Westside Electronic Music.